Alright, so we're going to talk about the chain rule. Now, let's talk first about what functions we can take the derivative of. For example, we know how to get the derivative of functions like x to the third. We know how to get the derivative of functions like cosine of x. We know how to find the derivative of square root of x, for example. And we know how to get the derivative of functions like x to the negative 4 over 7. And others, of course, but you know, if I get the derivative of each one of these, for example, this one, the derivative of that guy would be 3x squared. The derivative of cosine of x would be negative sine of x. Derivative of square root of x is 1 over 2 square root of x, and then the derivative of this guy would be negative 4/7 x to the negative 11 over 7. So this is stuff that we've done, but what about when we have a composition of functions? So for example, instead of x cubed, what if we wanted to get the derivative of a function like e to the x plus x squared all cubed? Or let's say we wanted to get the derivative of not cosine of x, but cosine of x to the fourth, for example. Or instead of square root of just x, we had square root of x to the third minus 7x. So, and let me do an example like this one. Instead of x to the negative 4/7, what if I have 3 to the x minus sine of x squared all to the negative 4/7. These are all examples of compositions of functions. All of these right here are compositions of more than one function, sometimes two, or it could be more. And so when you have a composition of functions, you know, the usual rules of derivatives don't apply because it's a different situation. So here, to be able to effectively deal with these problems, we're going to label the two parts of these functions. So we're going to have a outside function, which is this guy. So here, for example, this guy, this is the outside. And the inside function is going to be this guy right here. So notice that there's always a inside function, in this case e to the x plus x squared, and that's contained in the outside function, which in this case would be x to the third. Okay, so here, same thing. The outside function in this case is going to be the cosine function, and notice that the inside is x to the fourth. So the outside is cosine, the inside is x to the fourth. Here the outside is the square root, and then the inside is x to the third minus 7x. So that's the outside, this is the inside, and then right here, this is the inside. And then notice though, this one also, we've got two insides. We've got this inside, but then notice that this is sine of x squared. So we'll deal with that when the time comes. But the main thing to remember is that you've got an inside function and an outside function. So let's state the chain rule. Okay, so what the chain rule says is that when you have you're trying to find the derivative of the composition of two functions, so I'm going to label it f of g of x. And actually, let me color them in the same colors that I used over here. So f is the outside function, and g is the inside function. So this guy right here, this is the inside, and then f is the outside. So here, for example, using this first example that I have right here, x to the third would be the outside function, and the inside, what's contained inside of that function, is e to the x plus x squared. Okay, so what the chain rule says is that the derivative of a composition of functions is equal to the derivative of the outside function, leaving the inside alone. So the inside here, g of x, is going to be left alone. You're not going to do anything. You're not going to get the derivative of the inside at this step. And then you're going to multiply times the derivative of the inside. Okay, so let's put that in words. So we have the derivative of the outside, leaving the inside alone, times the derivative of the inside. Okay, so let's actually apply it for the derivative of that first guy right there. So I'll rewrite it down here. So we have the derivative. We want to find the derivative of e to the x plus x squared to the third. Okay, so the first thing to do is to label the outside and the inside. So right here I've got the outside function is this guy raised to the third, and then the inside function is this guy right here. Okay, so to find the derivative of this guy, remember, you get the derivative of the outside. So what you do is you pretend like this inside is just an x. So if this guy is just an x, then you're going to use the power rule. Bring down the 3. You're going to leave the inside alone, and then you're going to subtract 1 from the exponent. So if this was an x, this is exactly what you would do, except that instead of x, you're going to leave the inside alone, so it's going to be e to the x plus x squared. Okay, so we're right here at this step, and then times the derivative of the inside, which is the derivative of the inside is simply e to the x plus 2x. And that's it. You're done. Okay, let's do the next one. So the derivative of x to the fourth, we've got the outside, which we already said is the cosine function, and then the inside is x to the fourth. So we get the derivative of the outside leaving the inside alone. So the derivative of the outside is negative sine of x, but instead of x, it's going to be leaving the inside alone, so x to the fourth stays the same, times the derivative of the inside, which is 4x to the third. And that's it. Okay, so in this next example, we've got the outside function again, and then the inside function is this guy right here. And sorry, I made a mistake here. This guy is 7x. Okay, so we've got the square root of x to the third minus 7x. So we've got the derivative of the outside, so the square root is the outside. So now you can either do, you know, square root of x is x to the 1/2 and do it that way. But I like doing the other way that we talked about earlier. So the square root of, the derivative of square root of x is, if I get the derivative, 1 over 2 square root of x. So that's how I like remembering it. But it's up to you. So instead of 1 over 2 square root of x, I'm going to do 1 over 2 square root of the inside. I'm going to leave it alone. So x cubed minus 7x. And then times the derivative of the inside, which is going to be 3x squared minus 7. And that's it. Okay, so we're going to do, this is our first example of where it gets a little crazy, but not too crazy yet. So notice that when we identify the outside function here, you know, we've got this function right here. This is my outside. And this guy right here is the inside. But now notice that this guy right here also has its own inside. So when I get the derivative of this part right here, I'm going to have to use the chain rule again. So I'll deal with that when I get there, though. So my very first thing is you look at the very outside, which is this whole thing to the negative 4/7. So I get the derivative of that. Okay. So the derivative of that is negative 4/7 times, leave the inside alone, right? 3 to the x minus sine of x squared. Subtract 1, so negative 11/7. And then times the derivative of the inside. Now the derivative of 3 raised to the x is 3 to the x times natural log of 3 minus, now right here. So right here I'm at a new chain rule situation where I've got an outside function, the sine function, and I have an inside function, which is x squared. So I get the derivative of the outside function, sine, which is cosine. Remember, though, you have to leave the inside alone. So x squared is going to stay the same. But then you have to multiply by the derivative of that inside, which is going to be 2x. So the second chain rule is all right here, because that's where it appeared. And so now we close it. And that's it. We're done with that one.